Hi students, let us continue to do some more problems for finding inverse of a matrix. Suppose exercise 1.1, sum number 3. It is given f of alpha is, it is given cos alpha 0, sin alpha 0, 1, 0, minus sin alpha 0, cos alpha. This is given. What do you want to prove? Prove that f of alpha inverse is equal to f of minus alpha. So how to prove this? See, left hand side we need to find out, instead of A matrix it is given f of alpha because it is a function of alpha. Find out inverse of a matrix. You know how to find out inverse of a matrix. 2 steps. First step, find out determinant. Then if the determinant not equal to 0, proceed to find out adjoint of f of alpha, then f of alpha whole inverse. Right hand side we have to find out f of minus alpha. So let me take the right hand side first. Suppose I write right hand side. What is f of minus alpha? Let us replace alpha by minus alpha. So what will get? It is cos of minus alpha 0, sin of minus alpha 0, 1, 0, minus sin of minus alpha 0, cos of minus alpha. You know that already. Cos theta is an even function, sin theta is an odd function. If it is even, cos of minus alpha is cos alpha. If it is odd, sin of minus alpha is minus sin alpha. So let us rewrite the answer. Cos of minus alpha is cos alpha 0. This is minus sin alpha. Then 0, 1, 0. Sin of minus alpha is minus sin alpha, minus of minus plus. So I have sin alpha 0, cos of minus alpha is cos alpha. Okay, take it as 1. Right hand side we got the answer. Now how to get this left hand side? So left hand side, first step, find out determinant of f of alpha. So how do you get this determinant? Matrix cannot be expanded, but determinant writing within this determinant symbol. So now I take first entry cos alpha into, deleting this row and this column, I have 1 into cos alpha is cos alpha minus 0. Next entry, already it is 0 and everything will become 0. Now plus last entry is sin alpha. Deleting this row and this column, we have product of these two will become 0, minus sign. Now when you multiply these two, one more minus sign, minus of minus plus sin alpha. So what do you get now? Cos alpha into cos alpha, we have cos square alpha. This is 0. The sin alpha into sin alpha is sin square alpha. Answer is 1, which is not equal to 0. So determinant of f of alpha is equal to 1, which is not equal to 0. Therefore f of alpha inverse can exist. Next step, we need to find out adjoint of f of alpha. I told you. So we are going to follow only the shortcut method. I told you already. Write down the given matrix. This is only a rough column. Okay, so let me write down the entries cos alpha 0, sin alpha. Next one 0, 1, 0. Then minus sin alpha 0, cos alpha. Write down the given matrix as it is. Now repeat the first two columns once again. First column, so we have it is cos alpha 0, minus sin alpha. Now second column is 0, 1, 0. Now once again repeat the first two rows. So I have cos alpha 0, sin alpha, cos alpha 0. Second row, what do you have? 0, 1, 0, 0, 1. So totally we have 5 rows and 5 columns. Now delete the first row, delete the first column. Now take the first two columns alone. So I have 1 into cos alpha is cos alpha minus 0. So simply I have cos alpha. Second one, 0 minus 0, so answer is 0. We are finding the elements along the column wise but writing the entries along the row wise. Now this is 0 minus sin alpha. So it is minus sin alpha. Clear? Now the next one. Leave this column. Leave this 1, 0, 0, 1. And take the next two column. Look at this 0 minus 0, so it will become 0. Now this one is cos alpha into cos alpha is cos square alpha minus 1 more minus sin square alpha. Cos square alpha plus sin square alpha is 1. 0 minus 0 is 0. Now leave this column. Next one 0 minus of minus plus. So I have sin alpha. 0 minus 0 it is 0. Cos alpha minus 0 I have cos alpha. So now we write down the formula f of alpha whole inverse. This formula is 1 by determinant of f of alpha then adjoint of f of alpha. Whether you use capital letter or small letter, no, nothing matter. So adjoint of f of alpha. So what's the answer? F of alpha, determinant f of alpha value is 1. So it is 1 by 1. So simply we are going to write down what is this adjoint of f of alpha. Cos alpha 0 minus sin alpha 0 1 0. Now this one sin alpha 0 cos alpha. Now look at this 1 and 2. We have the same entry cos alpha 0 minus sin alpha 0 1 0. Okay. So from 1 and 2. Whatever is the question, you repeat the question once again. So we have proved f of alpha whole inverse is f of minus alpha. Hope you understood this. Okay. Now we'll try one more sum regarding this inverse itself. Now look at sum number 4. It is given A matrix. It is 5 3 minus 1 minus 2. Matrix A is given. We have to show that answer is A square minus 3A minus 7I2 equal to 0 and hence find A inverse. So first of all you have to prove this answer. Then from this you have to find out A inverse. Okay, so 2 steps here. So as usual simple thing. Look here. How to find out A square matrix? A matrix into A matrix. So be careful. So A square is A matrix into A matrix. So I have 5 3 minus 1 minus 2 into again 5 3 minus 1 minus 2. Yes, multiply row by column. So 5 5 is 25 minus 3. 25 minus 3. Then 15 minus 6. Next one minus 5 plus 2. Then minus 3 plus 4. What is the answer now? 25 minus 3, so this is 22. 15 minus 6, so this is 9. Minus 5 plus 2, so this is minus 3 plus 1. Okay? Then we need to find out 3 into A matrix. So 3 into A matrix, scalar multiplication of 3, 5, 3, minus 1, minus 2. Multiply each and every entry should be multiplied by 3. So I have it as 15, then 9. 3 into minus 1 is minus 3. 3 into minus 2 is minus 6. Then 7 into I2. So 7. What is this I2 stands? I2 is a unit matrix of order 2. So it is 1 0 0 1. Multiply 7 0 0 7. So we are going to find out the answer A square minus 3A minus 7I2. Okay. Look at this. So now I write A square minus 3A minus 7I2. So A square matrix already I have 22, 9, minus 3, 1. Minus 3A matrix is 15, 9, minus 3, minus 6. Minus 7, 0, 0, 7. Now look at the entries here. 22 minus 15 minus 7. 22 minus 15 minus 7 is minus 22. 22 minus 22 is 0. 9 minus 9, so this is 0. Then minus 3 plus 3, 0. 1, look at this. This is what? Plus 6. 1 plus 6, 7. 7 minus 7, 0. So we have proved a square. Therefore, we have proved a square minus 3a minus 7i equal to 0. Okay. Here the question is find a, hence find a inverse. So from this equation we are going to find out a inverse. So what I am doing, a inverse can exist only if determinant of a not equal to 0. So let us try what is the value of determinant of a. So already you have a value, a matrices. It is 5, 3, minus 1, minus 2. Product of the main diagonal, 5 into minus 2 is minus 10, minus sign, minus 1 into 3 is minus 3. So minus 10 plus 3, which is minus 7, which is not equal to 0. Therefore I can say a inverse can exist. Right? A inverse can exist. So what I am doing, you can take this as equation number 1. Pre-multiply equation number 1 by A inverse. So I have A inverse into A square, 3 into A inverse into A, 7 into A inverse into I, then A inverse into 0 will become 0 itself. A square is A into A. A inverse into A will become I. You know this. A into A inverse is equal to I. So you will have only A. A inverse into one more A. Okay. That will become I into A. Now minus this is 3 into I. So please remember, usually we write 5 into 1 by 5 will cancel, you will get it as 1. So likewise it is a matrix. Any matrix and its inverse, the product will get this identity matrix or unit matrix. Okay. Here I am taking A square as A into A. 1A, 1A inverse is I. Then 1A is remaining. Now A inverse into A will become I. Then any matrix multiplied with the unit matrix will get the same matrix. So minus 7 into A inverse equal to 0. Okay. I into A matrix is simply A itself. So A minus 3 into I matrix minus 7 into A inverse equal to 0. I wanted to have only 7 and A inverse. So bring this term along to the right hand side. Okay. So this will become positive. So I am writing 7 into A inverse equal to A minus 3 into I. Okay. So what is A matrix? Already I have 5, 3, minus 1, minus 2. A matrix minus 3 into I matrix. I matrix 1, 0, 0, 1. So I have 3, 0, 0, 3. Subtract. What will get? 5 minus 3 is equal to 2. 5 minus 3 is 2. 3 minus 0 is 3. Minus 1. Minus 2, minus 2. Minus 2, minus 3. So minus 5. Okay. So therefore A inverse is 1 by 7 into this matrix. So 2, 3, minus 1, minus 5. So we got the answer. This you can verify also. Look at this. If this is A matrix, A inverse, usually how will you find out? 1 by determinant of A into adjoint of A. Right? 1 by determinant of A. Determinant of A, just now we got it is minus 7. How to get adjoint? Interchange a main diagonal. Change the sign of minor diagonal. Minus 2, minus 3 become minus 5. Change the sign of minor diagonal.